Yes, good evening once again. Can you see my screen?
Yes, it is visible.
Okay, okay. And I think it is shared. You can see the R environment, R studio. Hello?
Yes, it is visible.
Okay, thank you. So welcome to our today's session. And we are going to cover about introduction to R programming. So we are going to look at operators in R. So as we will be covering operators in R, we are also going to cover variables in R. So the first element in terms of operator is the arithmetic operator. Arithmetic operator is where we can be able to compute, carry out mathematical operations on our variable or on our data. So in this case, I have initialized. So this is how we assign a variable in R. You can assign a variable to a value in R in this way. So we have two ways of doing that. You can use equal to. So for example, x is equal to 5, maybe x is equal to 10. And you can also use y is less than or equal to, is less than. And then you use which symbol is that? It's like minus. Yeah, and 20. So we use this. We have two options in R to be able to do this. We either assign using the equal sign, or we use the less than and minus sign together to assign a value to R. So this is the R environment, and here where we are writing is a script. We write in the script where we can be able to write our code. We have also console in R where we can be able to do a direct piece of code, run direct single code at a time. But R script allows us to be able to write a lot of the source code at the same time. For console, you have to perform your analysis line by line like that, and now you can call your variable x, what is the value of x, and you can call what is the value of y. That is the console. While in the script allows us to run these things at the same time. So I can have here what is y. This is how we call the variables in R, and what is x. So I can just, for you to run a section of your R code, you highlight like this, the section you want to run, and you click on run. You click on run here. Or sometimes you can just click on Control Enter, and it will be able to run a section of your code. You can see another output here under the console. So I can clear my console like that. You click on the erase, which will be able to clear your control. There is a shortcut for that, which is Control plus L, but you can clear just here. And I can rerun using Control Enter, and there we go. So it will write this code to this console and give the output. On the other side, hand side, we have the environment where any variable that is being initialized to the value, or you'll be able to be visible here. Any variable initialized to any value will be able to be visible here. And you can also be able to see files, see plots, and the packages that you have in R just down here. You can be able to see the packages you have and the plots in case you generate plots in this. So that's the introduction to R, and we have just initialized our variable x. We have assigned a value of 10, and y we have initialized a value of 20. But now we usually recommend being consistent. You either choose using equal to, or choose to use less than or equal, less than or less than minus symbols. So for me, I usually go with the less than minus symbol in R. It's the most recommended. You can use equal to. Okay, so some of the simple arithmetic operations in R we can just perform an addition in R. So for example, I can have a variable. I can have a variable A, and I assign a variable A a value of 35, and create another variable B and assign it a value of 15. And when I need a variable C, maybe computed from A and B as a plus, which is the sum, or sometimes I can just call this sum without using this. I can just call this sum or summation. Yeah, just sum, no problem. So I can run this and then call the variable sum here. Though sum is a key, sum is a keyword in R. So let's see. Sum is a keyword in R, but it has been able to be assigned a value of 50 here in this case. So you can assign a variable C and perform the sum just like that. So that's how we initialize a value and carry out a simple math, which is addition in R. You can also conduct subtraction in R by using minus symbol just in here, and you can compute your subtraction like that. Or you can compute your multiplication, just changing here to multiplication, and there you go. You'll have the multiplication. Or you can change this to division. You change this to division using that symbol for division. Like that. Yeah. And now we go to some special arithmetic operators, exponential and modulus. So exponential raises a number to a power. So in this case, if we have z and we want to assign it the 2 to the power 5, then we can just run that in R. So R runs code from top to bottom. So like here, when I click on run without selecting the whole data, it will be able to assign it a value like that. And then I run again. So it runs line by line like that. So my value of 2 to the power 5 is 32. So that's how we compute the exponential. And modulo returns the remainder when a particular division is performed. So for example, 28 and 6, when we cut out the x, which is 28, will be assigned 28 modulo 6. It will be able to return the remainder, which will be around 4, because we know that 28 or 26 goes to 28 4 times, remainder 4. So it will be returned the remainder and not the 4, which is that it is divisible by that. Are we carrying out the modulo? Dennis, what does modulo do? Or Z, we had already assigned it another value, so we use another element here, because I'm just seeing some unnecessary drama. X and Y. Okay, let me just run these things well. Let me just call this, it was Z, so maybe I run. Let me just see if, yeah. That's now it's running well, because it was taking another value for Z and not the value that you are initializing here for X and Y. Because we had already defined X and Y at the top, X and Y, sorry, I think there was X and Y. Yeah. So Z had already taken some value before, and now we were calling it. And that's why it was returning some things that we don't want. So you can still clear the environment and to clear the variables that you have already defined. And you can reuse the variables as well. But you can still reassign the variables another values, and it will be able to reassign it another values. So in this case, we have just seen the circumstance, how it led us to the first input, which was incorrect, because we had not defined, we had not run this and run this to activate the values of X and Y. And then now be able to assign a value to Z, to our new Z, which is x modulo y. We can just say modulo. So we can just assign it modulo, and now we call this also modulo, so that we can differentiate it from the previous. So, and then now we can run this together, and we see it is actually the remainder when you divide a number by another number. Like how many times does 6 go to 28? 4 times. Now, which is 24. So you take 28 minus 24, you get the remainder, which is now 4 in this case. You can still use another value. We can change this to another value like 30. And the remainder here will be 0 because 6 goes into 36 times, 5 times. And now the remainder will be 0, like that. Okay, so we can move to variable assignment in R. Variable assignment in R. Variable assignment in R. So assign the value 10 to the variable called my age, then print out the value of the variable my age. So how do we do that? So we use my age, we assign it a variable. So a way of naming variables. There are rules for naming variables in R, as it is in other programming languages. So as usually say that variable names can contain letters, small letters, and uppercase and lowercase, and then can contain underscore. Can contain underscore. Does not allow a blank space in between. For example, my age cannot allow space. You either include the underscore. What if we put a special character like and, like an at, and try to run our code and see what it tells us? So the rules in naming variables, we have encountered an error because we have rules for naming variables. So while naming variables, you ensure that you use small letters or capital letters. But when you want to separate, you only use underscore. Underscore is the one that is only allowed to do that. So we have assigned the value 10 to the variable my age, and now we call the variable my age, and everything is running well. So that's how we assign a value to a variable, the way we did in the previous section. And yes, you have score 1, max, which is 80, and score 2, max, which is 60, and you want to add them. We looked at the addition in R, where you can be able to assign a value to a variable. In this case, we run this. So score 1 has been assigned a value. Here, when you look at the console, you can be able to see your code. And then we click again to assign score 2, value of 60. And then now we run the total. We assign the sum of score 1 and score 2 to total score, like that. And then when we want to print it out to the user, we just call the variable itself, like that, which is 140. Or we can use the print function in R to call, just like other programming languages, we can use the print in R to call these variables, like that. The variable has already been assigned, so you can still use print. The total score not found. Hope I'm writing the right thing. Total score is capital S, not small s. So while naming variables, the R is case sensitive. You need to ensure that you call the variable while ensuring that you're calling it with a specific name. For example, we just used small s instead of capital S to call the variable which was total scores. So you need to ensure that your program or R is sensitive. Just want to ensure that while naming variables. So let's go to data types in R. Data types in R, basic data types in R. So we have numeric data types, like the ones that contain decimal values. We have integers. This one contains the whole numbers. And we have the Boolean values, true or false, which are sometimes called logical in R. And then we have characters, which are just text and string values. So checking a data type using a class. How do we check data types? Which use check a data type of a variable using class function. So class function can be able to tell us which type of data type it is. For example, Dennis, which data type is this? The total score here, 140, based on data type, basic data types we have here.
It's an integer.
Yeah, so it is an integer. Thank you so much. It's an integer. So we can just check that using the class function. And then we run this. Sorry, let me run. We are here under class for total scores because we have not assigned my name any variable, so it will not be able to do that. Yeah, so it is numeric. It is numeric, which means that it's an integer. So it is numeric, which is an integer. And we can call class. So sorry, let me assign another variable here also, but pi. Let me assign pi to be equal to 3.14. And again, check the value, check the class, the data type for pi, class for pi. What is the class for pi? So object pi not found. I have not just run this at the top. You have to ensure that R runs everything top down. So you have to ensure that everything is okay. So class of the class total score is numeric, and pi is also numeric. But class is the total score is numeric, but it's a whole number, while pi is numeric, but it's a float, which contain decimal values. So that is the difference between the two types of numerics. And we can now proceed to my name. So maybe my name, I can say John Doe. John Doe. And now I assign my name variable known as John Doe. And now I want to check which class is this name. So this one will be a string. This one will be a string. So we run this, my name, we assign a value John Doe. And maybe we can print the value first of all, the name, my name. We call my name to print it to the screen. And now we check which type is it. It's a character, which means it is a string. And my height, we can also do that the way we did for the pi. And it is also a numeric. And we can check Ismail using Boolean. This is Boolean. So it will be a bool for Boolean. So we have assigned true, that is male. So we check the class. It's logical. We say that Boolean operators, they are referred to as logical in R. So an assignment you're supposed to do is just to create any variable in R. So maybe Dennis, are you having your R Studio with you? Open?
Yes, it is running.
If it is open, then you can share your screen. Maybe here under assignment, you can just assign to us any variable and call the class of that variable. I can stop sharing and you can share your screen so that we can, you can run that on your end and then we proceed.
Yes.
Yeah, you can share your screen. Just share your screen.
I hope it is visible.
Yeah, it is visible, Dennis. Nice. Assign their variable, then check the class of a variable. You can check a class of your variable. So we use the class function to be able to check. Maybe you can just maybe define a variable there, maybe your name, and then you check using the class. Yeah, so just, and then now you call the class of that variable.
It's bringing an error.
So just run one by one. Just run one by one. Just run one by one. Ensure you use class small letter. Class use small letter.
I guess
Yes.
that's the
And then you run. Yeah. Every time you call a function or any keyword in R, you must use a small letter.
Okay.
And you run. Yeah. There you go.
Character.
Okay. There we go. So we can proceed. You can stop sharing so that I can be able to share mine as well. So, okay, just confirm with me if you can be able to see my screen. Can you be able to see my screen?
Yes.
Okay, now we are going to vectors in R. A vector in R. So a vector is just a one-dimension array that can hold numerical, character, data, or logical data. So we create a vector with the combine function, separating each element with a comma in R. So for example, here we have created our first vector, which is a num vector, vector of numbers, 20, 30, and 40. So we use the combine function to be able to create a vector. And we can even print that vector to the user. So here we are creating two vectors. So the first vector is a vector of numeric values, and the second vector is a vector of string values. And we can be able to run that and then call those vectors to the screen. So we can run that and run this as well. And we can run now to see to the screen how a vector has been created, and also run this other one to see how a string vector has been created. So maybe complete the code for a vector, for the Boolean vector. So Boolean vector, that means that you can create a vector of bool vector. Let me call it bool vector, bool underscore vector, and assign it the vector values using, okay, we said that for us to be consistent, we must use that symbol to assign variables. And maybe true, which is a logical vector. So we say true, you see. So keyword, for example, the stored keyword here, which is Boolean, for Boolean, which is true and false, we write them in capital letters for them to be recognized as stored keywords in R. So that's how we create a vector of Boolean vector of Boolean characters. True, false, true, anything. And then now we can just run this and then call this to the screen. So Boolean, we don't separate them we don't put them in the quotes like other strings for them to take their Boolean meaning. So we can run that and run this. And there we go. We have a Boolean string of characters in R, a Boolean vector, yes. So how do we name a vector? So give a name to the element of a vector with the names, So let's see how does that work. So we are going to look at that, how does that work? And we will be going to give names. So we start here by looking at a particular scenario where we have our patient. For example, we need to keep the records of the patient from a particular week, and we note the patient. Maybe let's say the day the patient came in, Monday, another patient on Tuesday, another patient on Wednesday, another patient on Thursday, another patient on Friday. It's just an example. So we can create a vector of days: Monday, Tuesday, Wednesday, Thursday. Vector of days. We can create a vector of names of people, and then we can create a vector of their age. So these are different vectors. So we are also going to learn how to combine these vectors like that. So you have created 3 vectors. And now maybe we want to give names to these vectors. That's where we go now. Give a name to a vector. So we use names function in R to be able to assign a name to a vector. When we just call these vectors here, for example, day, when we just call day, so we wanted to assign names. That's why we started by defining. You define all the vectors that you have, and now to assign names to those vectors, you use the names. So maybe in this case, the names we want to use is the number of days, the day of the week, the name of the day of the week. So let's just run this and see, and then we'll be able to explain more so that we all see what's happening. So for example, Jane came on Monday, Mark came on Tuesday, Anne came on Wednesday, Robinson came on Thursday. So how does that work? So that one enables us to be able to assign like columns. Is like creating column names. Yes, column names of your vector. That's what we call names. Those are just column names. For example, in that case, like column names. Let's take it like that. So what if we have age also? So we can also assign the same way we did for the names. We can also do the same for the age using the names function in R like that, and we can also call it. So you can see. So on Monday, 56, Tuesday, 45, Wednesday, 23, Thursday, 46, and Friday, 27. So this doesn't really make a lot of sense to us, and we will later learn on how we can combine these different vectors to be one vector. So can you see my screen still?
Yes, it is still visible.
Okay. We proceed to arithmetic calculations on vectors. So R takes the element-wise sum. So we can have a vector of numbers and another vector of numbers, and we want to combine these 2 vectors. So what R does is this. So you can assign, let me say we assign this to a vector Z. Let me see. The total, we assign it to a vector Z, and then we will call this vector Z. Yes. So we have a vector here and another vector here. So maybe let me just make it simpler by doing this. So A is equal to the first vector, which is C. Sorry, use this consistency. 1, 2, 3. And vector B takes values 4, 5, and 6. And C, now Z, let's use Z, will be the computation of vector A plus vector B. Yeah. There we go. Now we can run this. We assign it, and then we assign vector B, then we compute the sum. So it will be combining 1 with 4, 1 plus 4, 2 plus 5, 3 plus 6. That's what we expect. So when we run Z, we'll be able to return the total. When we call Z now, that is Z now, we call the Z. We have assigned it the sum. Now we call it. And we have 5, 7, 9. So that is what it does. So this is just a shortcut way of doing it. And this is what we are just meaning that is going to perform. It's just the same. You'll get 5, 7, 9. So that's how we carry out our arithmetical calculation, just like sum in R. So consider arithmetic of vectors using variables. So I have just already used the concept of variables here, but you are just expected to use this one. But there's no problem. It's just the same thing, only that we realize the importance of variables. That's why we introduce the concepts of variables like this one. So for example, in this case, we have scores for particular the score 1 for the student, for our students, for our 5 students, and we have score 2 for our 5 students again, and we need to obtain the total scores. We need to obtain the total scores for maybe per student, or per student, or maybe per subject, or per score. So in this case, we want to start by assigning this variable. We want to assign it this vector for score 1. Score 2, we assign it this vector. So we'll just run this and run this. Yeah, and then the second one, the second part is we want to compute the sum of score 1. So how can we compute the sum of these vectors, the total sum of these vectors, like 56 plus 78 plus 45 plus 67? So we use the sum function in R to be able to compute the sum of this vector. So you can just run that. And then the second one, we are also computing the sum of score 2 in R using the sum function. We also run that. And now we check the output for the sum for the score 1, which is 335, which is 335, and the score 2, which is 312. And suppose we want the total per student, maybe, and we have student names. You see, we are combining concepts here. Maybe we have student names A, student B, student C, student D, student E. Yes, we have assigned that. And now, remember, we are now combining the concept. We learned about the names in R, and now we want to assign these student names to these marks that we have stored in these variables. So how do we do that? We use names, and then we specify the variable in the double quotes, the variable that we want to apply this vector of names. The same way again, this vector of names, we assign them to the second scores. So let's run that in R. So that's how we do. You run, and you also assign that one. And now, right now, when you call class score 1, let me first of all call this class score 1. We'll see the difference. It is 3, 3, 5. And now when we come here, and this was total, and now this one we are now referring to, this one was the total. So right now when we call class score 1, the class score 1, it will not be this one alone. It will be attached the names for the students. Each name of the student will be attached to each value. So we can run score 1 and also run score 2. You see, each value of the student has been assigned to the name of the student, which is name A, student A with 56, student B with 78. And again, we can run also for score 2, which also students have their scores for 2. And suppose we want to combine these scores, score 1 and score 2, to produce another variable known as total student scores. Like you are combining cat 1 and cat 2 to create cats, create cat performance. So total student scores will be you run this plus this, the way we learned about adding vectors in R. And we have assigned it a value, and now we run it. And now we see we have the totals. So it's 56 plus 67, you get 78 plus 78, you get total. 45 plus 76, you get total, like that. So up to there, hope we are together.
Yes, we are together. I'm still learning.
Okay. Okay. Then now we proceed to using comparison operators in R. We have learned about the vectors in R. And once we learn about comparison operators, we will be able to do more. So you see our concepts are piling up from defining variables to computing simple arithmetic up to now assigning variables to R. So let's say we want to compare comparison operators returns a logical value. So for example, we want to compare the operators or the vectors. We want to compare vector values. Maybe the value in score 1, we compare to the value in score 2. Let's run this and see what it's telling us. So what this R is doing, imagine it is comparing the vectors we had, the vector for score 1 and the vector for score 2. If the student performance in cat 1 is better than the student's performance in cat 2. Dennis, do you see that?
Yes.
Yeah. So you see, it is returning false if the score 1, which is 56, we are asking, is 56 greater than 67? Then R is telling us false. Next, is 78 greater than 78? It's telling us false. And then we continue, is 45 greater than 76? It tells us false. Is 67 greater than 34? It tells us true. Is 89 greater than 57? It tells us true. Actually, that is what R is doing here. It returns the logical values, which are true or false. Again, we can also test the total scores for cat 1, which is score 1, and the total scores for cat 2, which is score 2. We want to compare if 335 is greater than 312. So we expect it to return true. We expect it to return true. And there we go. It is true. It is true. It is true. So now we proceed to accessing vectors. Accessing vectors. Maybe, for example, you want to access the vector elements of your data, vector elements of your vector. So in this case, maybe we want to access the student at the index 1. So let me just call this and run it again. I think we can just call it here, class underscore score 1. Just that one without the, yeah, score 1. It's capital score 1. Score 1, yeah. So let's call it to see if we define the variable well. Yeah, and there we go. So what we are doing, we want to access the element in the first index, in the first position of our array, of our vector. I want to talk about arrays. So of our vector. So this is how you access the first element in the first position of our vector. Maybe you want to access the third student, the third element in the vector of our student. We return the results. That is 45. Okay. Maybe we want to access multiple vectors. Maybe we want to access the first, the third, and the fifth student in the score 1. We can do that using this combine function in R enclosed in the square brackets. In square brackets, while attaching it to the variable name of the vector. And now we call it, we have accessed our first, third, and fifth elements in our vector. So we can also still use a range to access the elements. Maybe let's say we want to access the second, third, and fourth. We can use a range by just attaching the access point. Yeah, like that. Now you have access to the third, the fourth, and the fifth in R. So access student using their names. So once we define names to the vectors, we can also access the elements of a vector by specifying the names. So for example, you can access the student scores for class in the score 1 by referring to A by their name, because A is the name of the student. Student A is the name of the student. So you can access it in the double quotes inside the square brackets, attaching it to the variable. So you can just run this to access, and there we go. It's very, very, very simple. And the same way we did for multiple access to the elements of a vector, you can specify also the names of the vectors in the quotes in your vector using the combine function, and attach it using the square brackets to the variable, and you can be able to access it like that. So up to there, we can now introduce matrices. A matrix. We can now introduce a matrix. So matrix is different from a vector because a matrix only contains the elements of the same data type. Unlike a vector that can take different data types. So a matrix is a collection of elements of the same data type. So for us to create a matrix, we use a matrix function in R. For us to create a matrix, we use a matrix function in R. So for example, we are defining here a matrix, and our matrix is taking values from 11 to 22, a range of 11 to 22. And so our matrix function takes 3 arguments. The first argument is the range of your data. The second argument is by row. So do you want it to arrange your data by row, or do you want it to arrange your data by column? So if you say by row is equal to true, it will be able to arrange your data based on the rows. And by column, it will be able to arrange your data based on the columns. We are going to see what does that mean. That means that that's your column names. Like your column names, are they in transposed form, like transpose into row names, or do you want it to do it the other way around? So for us, we're just saying false. And then the number of rows do you want based on the data that you're defining. So for us, we need 3 rows. So let's run our first matrix in R. So our first matrix here has taken values from 11 to 22. And it has categorized this data into how many rows? 3 rows, the way we specified. Row 1, row 2, row 3. And by row, which it meant by row is the arrangement. Let's change this to true. You'll see how the values will change. We see we have here 11, 12, 13. You see? Because it is by column. 11, 12, 13 is by column. 14, 15, 16 is by column. Let's change to by row true. By column is the false of by row. So let's change this to true and see what will happen, because here we see it is 11, 12, 13, 14, 15, 16. The other way, let's see what will happen to that. And here we have 11. You see now by row, it is true. Now it is the other way around. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Do you see that, Dennis? Dennis, do you see that difference? Yeah, do you see that difference? Okay. And that is it. And then we go to collection of elements. So by row, we said it is true if you want matrix elements to be filled by rows. N row is the number of rows. These are the arguments or the parameters that the matrix function take. So there is also another example here. So maybe Dennis, you can run this example on your machine. Let me just copy this and paste it the chat section. So you can be able to show us. Can you be able to show us how we run that? Yeah, like that. Yeah. So there we go. And there we go. All right. So let's proceed. Thank you. You can stop sharing your screen so that I can also share my screen. So analyzing matrices in R. So we are going to look at the health data. So a health data example. So we first of all start by creating, we are starting by creating vectors. We start by creating vectors. We learned about vectors. So we create a vector of employee ID, an employee name, employee gender, employee age group, and I think this is just employee data, not even health data example, but no problem. Let me just leave it like that. And we have employee ID. We assign some range of vectors, a range of values in the vector of employee ID. We run this, and maybe we may want to see what is it. So we can just write here emp ID to run and see what has been assigned. So these are the values that have been assigned. These are the values that have been assigned, which is 101, 102, 103, 104, 105. So levels are just levels are just the unique values we have in our data. So if we have repetition in our data, levels will only still be unique values. Yeah, so that's another discussion for another day. And the employee name, we can also assign the employee name like that. And then we can also assign the gender of the employee. We can also assign the age group of the employee, 18 to this to this, like that. And then employee salary. We then attach the salary and also the salary variable. And then the column names. You see, these ones are vectors. These ones are vectors. And now we assign column names. These ones will now take each column of these vectors in R. So that's why we have here column names. So that we are going to use the name function we learned in R to be able to attach these names to our vectors and our matrices, our matrix. So I ran that. So I have assigned that. So combining vectors into one matrix. So we are going to combine a vector into one matrix. So first of all, we start by combining vectors. So let's run by combining this vector. So we just run this. So we have combined there a vector. We have combined there a vector. And we run this as well. We run this as well. So it's mixing up these things. But I think this is not an appropriate example to show us on how to combine matrices, because matrices require that we have data of the same data type. Our data is not of the same data type, and we cannot be able to use it as a learning tool for matrices in R. So maybe we create matrices of same data type, because when we proceed with carrying out computation in R, it will bring problems into it. So this is not an appropriate example of training how to use matrices in R. We needed that our data needed to be of the same data type. For example, if it is numbers, it is just numbers. I can just take two scenarios and maybe we use that. So I can take the employee salary and maybe the employee height or age. Yes, employee age, employee salary. And then I can create another variable here, employee age, Yes, like that, employee age. So employee age can take values and maybe, yeah, like that. Employee age, 78 is too big. Yeah, so I think there are 5 values like that. And after that, we are going to create the column names for this. We are going to create the column names for this. We're going to create column names for this. So let me just remove these ones. I can just create more space here and move down like this. Yes. So here we are creating what we want just to explore. We are not going to use the example for the data that is above. It's not an appropriate example to use. So we want to create column names for our data. So column names, we just say maybe names or column names. Column names. For us, we want to name this one in this way. Yeah, column names like that. And now we are going to also create a vector of employee salary. And next one is into brackets emp age, like that. Yeah, and now we can run this and run this and run this, and we want to assign combine our vectors. We want to combine our 2 vectors, which is this vector and this vector. So let me first of all run this salary, employee salary, and I also run employee age, and I also run the column names as well. And now I want to combine this as details, employee details. Yes, employee details. And now how do we combine? We just use the combine function in R to also combine these 2 vectors. So the first vector is emp salary, and the second vector is emp age. Yes. There we go. And we run that. Nice. And now we can print this to the user first of all to check if everything is okay. Employee details like that. What is it? Okay, this is this side. Okay, this is this side. So this is how we create a matrix. And now, once the matrix has been created, this is like a vector, but now a matrix has been created, is a long one. So we use the concept of matrix to break this down. That's why we require it to be of the same data type. We require it to be of the same data type. Even this one is still realistic because we can still break it down. Yeah, we can still break this down further. The example above. So let me just use the example here, and then we'll be able to go back to the example above. We can break it also down the way we want it to be broken down. So let me use a simple example because it concerns this, and we can be able to use the same to learn. So we want to create a matrix, and a matrix we want to create is just a matrix of the same emp matrix. Maybe let me call it emp detail matrix. Emp details matrix. It will be a very long name. So let me just call emp matrix, emp mat details. Yes, emp mat details. And from here, I call the matrix we have here. This, not the matrix, the vector we have here, which is employee ID. This is what we take as a collection. So I use the matrix name, the matrix function in R, and then we put the collection, which is a collection of vectors, separate with comma, and then we now say by row. By row is equal to. So our data, we need it to be arranged by column and not by row. By column and not by row. So we'll say by row is equal to false. Let's see how our data will be arranged. Of course, we have the ability to change in case anything is wrong. And how many columns do we want? Columns is 5 columns. N columns is 5 columns. Yeah. So we need our data to be arranged by, in terms of columns. Let's see what will happen with our data, and then we'll be able to amend anything that we want to amend, because we have the potential to view our data. So let me run this code and again run the lower one. Let's see how the data is arranged. Yes, it is not the way we want. And now there is where now we come in with another concept. So we say by row is equal to true. We change by row is equal to true. And let's see how it is going to happen. By row is equal to true. And let's see how it's going to happen. And we run again. And there we go. Now we have our data in the design we want it to be, in the mode we want it to be. We want all the salary to be in the same row, and we want all the age to be in the same row. So that now each column will define each employee, each employee, each employee, each employee, each employee. And maybe we will also require row names. Row names, these ones are the row names, not even the column names. Let me change this to row names, and then we will now take the column names as these are the row names, and now we create column names as the names of the employees. Column names. See, this is just like English. You try to play around with things until they make sense. So column names, we are going to have employee names. So we can have employee name A, employee name B, employee name C, employee name C, employee name D, employee name D, and then the last one, because there are 5 employees. Employee D or E. Yes, E. Nice. And once we have that, we can now rerun this to take the row names as the employee salary and employee age, and the column name to take that. Yes. There we go. There we go. There we go. Now we have created that, and we have our vector here. This is our updated vector, and maybe we may want to, let me say, naming our matrix. We give the column names to our matrix, and we give the row names to our matrix. So how do we do that? Let me just run our updated matrix and see. So you see what we mean is the column names are this. Column names are this, 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 this. You see, we don't have that, and this data doesn't make meaning, doesn't have sense. Row names are this. So how do we add the column names to our data? Let me just take this down so that we get more space. So the column names, we use call names function. Call names function. Column names function in R. And what do we want to assign? We want to assign to the emp matrix. To the emp matrix. Emp matrix details. Emp matrix details, we put it there. And what do we want to assign it? The column names are known as column names. Now that's why we had this before. That's why we had this before. We copy this and we paste it here. And we can do the same for the row names so that we do everything at the same time. And maybe we can just call this function here before we assign the row names into it. Mat details. And now we go to row names. Row names function in R. And it's going to take the value emp details, emp mat details, like that, emp mat details, and we are going to give it the values in the row names. So we use row names. These names here are going to the rows, and these names are going to the column. That's what we are trying to do here in R. So we run the first one. And we call it. Now you see, we have given the name of each employee to each column. So maybe we want to know which is this data about? This data is about the first row is about what? The second row is about what? So we run again, and we call again our matrix, mat details, this one. And when we call it, it has additional information. Dennis. Dennis, are you there?
Yes, I'm following.
Yeah. Is everything flowing? Let me post this code to your end, because this code you don't have it. You cannot get it anywhere. So let me just post it there so that you can also reference to it. Yeah. Yeah. Yes. That's how we do that in R. So we have just given some dummy names to our columns, and dummy names of our salary and age in the rows. So that's what we call a matrix. That's what a matrix is. That's what a matrix is. And we can take just the example we had above and continue with it below. So at least we have an understanding of simple data. So maybe we can take this full data, cut this and take it down. Let me just cut here from here, create variables and stuff like that. So yeah, and then take it down here so that we can continue with it to in depth. So at least we have understood what this code is going to be about. So we started by creating, assigning vectors, and the column names, the names that will be in the columns. So combining a vector into one matrix, so that's what we do next. So we combine these vectors into one matrix. So the first thing, we can run this to assign that, and then run this. So this is how it is looking like. This is how our data is looking like. The data has been combining all the vectors together. It's not yet a matrix. It's just a combination of vectors together. Not even a matrix yet. So you have combined the different vectors together, and now we want to create a matrix out of these vectors. So we call the data for the vector, main vector we have created here. We say by row is false. And by columns, we need how many columns? 5 columns. Let's see. 1, 2, 3, 4, 5. So we want this one, A, and other elements in the same order to be in the same column. Like details about the employee ID, we need the employee ID, we need the employee name, we need the employee gender, we need the employee age group, employee salary, to be in the same column for one person. For the second column, for the another person. Third column, the third person. Fourth column. And that's what we are trying to do here by assigning a matrix into it. So maybe can you mute? I'm hearing some noise from the background. Okay, thank you. So by row is false. That means that we want to arrange our data by column. And then we specify the number of columns. Number of columns is 5. So we can run this data to do that, to create a matrix, and we can run it to view it. You see? So what does that mean? The first person is having details here about the first person. The name, the ID, the column names, ID, the names, the genders, and the age group, and the salary. And the next thing we want to do is to assign column names and assign the row names. That's what we want to do next. So naming a matrix. So we start by adding the column names. Let's add the column names the way we did for the first example, like that. And we run again. There we go. We are creating a very good table here. And we can proceed and also assign columns and the rows. Sorry, the rows I think is assigned down there, but we can still assign here. So the way we did names, row names. Sorry, we are doing rows. So row names. Change this to row names, small letters. Row names. And we call this our matrix p data, and we specify the row names. So row names is, so this is just employee ID, employee name. It doesn't even require to have row names, but we can just give them serial numbers. So our row names, we will have to assign row names into it. So we create here row names first, a vector of row names. So we can just say row names, row underscore names, and we assign a vector of serial numbers, which is just 1, 2, 3, 4, 5. Yes. Now we can run this. Okay. Then now we call that here. What we have just run, row underscore names, like that. And we run. This. Good. And now when we print this matrix, it will have both the column names and the row names, like that. Now the row names, yeah. So you see, we have 1, 2, 3 on this side, and we have the column names at the top. Yes. Dennis, we are together, right?
Yes.
Okay. Then now we go to matrix calculation. I'm just about to finish. A matrix calculation. For example, we want to get the column totals. We use the column sum in R. We use column sum in R. So remember, a matrix requires that it should be of the same data type throughout. For example, the numeric data type. You can be able to compute their sums. And in this example, let's try to calculate the sum for the. Let's try to run this and see what will it give us. Column sum. Let's see. Any numeric data that is in here should be able to be calculated. Any numeric column. Let's see. And our numeric column here that we have, x must be numeric. That's why we say that when you are creating your data type, you need to ensure that your data is numeric. You can see here everything is text. Everything has been quoted to be text in this matrix. Everything is text. Text is always quoted in there using the double quotes. So we can just reference to another matrix. Maybe if we could have had a matrix of row numbers, because immediately you mix text with the raw numbers, we can compute. I think we had something like that about the example we had previously before we came to this one. So you cannot be able to compute that sum. So you can be able to compute the example we had about the emp maths and stuff like that, how we can compute the sum function. Let me just go to where we were and matrix sum. Down, not there. Yeah, just here. So we wanted to compute the total sums for a particular column. But now we cannot be able to compute the total salary sum. Because why? Our matrix is not of the same data type. We need to ensure that it's of the same data type, which is when we want to compute sum must be numeric for all the data types that we have. So in this case, we cannot be able to compute that. Now we go to the data we had here before we came to this example, and maybe we want to compute the totals. Let's say just totals, and then we say column. So it is row name. Our data is was arranged in rows or columns. Let me just run this before we do this. Let me just run at the top so that we understand how this data looks like. Okay, so we can be able to compute row sum and not column sum because our data is defined in terms of row. So salary, we can compute the total salary, we can compute maybe the total age, which does not make sense, but we can be able to compute the total age, no problem with that. So we cannot be able to compute the sum for, we cannot combine salary and age together. That's why we are not collecting column sum in our example here. So we can be able to compute the row sum. So you can say total salary, just total, let's say totals, and we'll be able to see what this row sum will tell us. Row sums, this one, row sums, and we call emp mat. Let's see what is it telling us. Sorry. Let's see what it's telling us. And maybe we call the totals. It should be able to bring all the totals together. So all the totals for salary and for the age. So it is bringing emp salary total here, emp age total here. Yes. So it computes the total. That's why you cannot be able to perform if your data contains different data types. It must have the same data types. And when you compute sum only happens to numeric data. If your data is not numeric, all data is not numeric, you cannot be able to use sum. So a data frame is the one that allows us to be able to compute sum-wise, because a matrix requires that we have the same data type. A data frame, we can be able to we combine this data, and now we can be able to compute each sum. So we will be able to look at how to create a data frame another day and be able to compute sum. That's why we had this example here to enable us learn that and understand that a matrix contain only same data types, and if possible, if you need to compute to carry out computation, let it be numeric. Data frame, you can have different data types, and you can compute sum on any column you want to compute. Yes, so that is it. And assigning names, we have learned that. Row names, we have learned that. And computing the total sums. Yeah. So let's look at an example here. There is an example here that we want to look into that now gives us a bigger view about what I just said, that your data must be numeric throughout. For example, this table here, your data must be numeric throughout for you to be able to compute the total scores for maths, the total scores for science, the total scores for English. We have learned other things at the top. So we are going to learn about adding rows and columns to a matrix. Adding rows and columns to the matrix. You can add rows and you can add columns to a matrix. So you can add a column or multiple columns to matrix with the cbind. And you can add a row or multiple rows on a matrix using rbind, which stands for row. Cbind stands for column. All right. So that is it. So let me check if I have. Let's use this example to learn, because when you go back to the top and try looking at the examples, it will not make sense. So let's use this example here. So you have student ID, we take the ID of the student. Student scores, we take a vector. Science scores, we take a vector. English scores, we take a vector. After that, let me just run that so that when I reach to the bottom, I take a vector. So, okay, yeah. Just forget about this, because these ones are just, that's why you have this error here, but it's no problem. So we continue with that. We continue with maths, assigned value, science. We assign science value, we assign English value. Yes. After that, now we create student data. Student data is now a combination of these different vectors to be one vector. So we combine it using the the combination. We've learned the combination function, and we can now run this to check our data. So you see, our data have been combined into a long data, just a combination of data. So from there now we go to how we can check the dimension of our data here. So our dimension of our data here, we see the dim for the student data is null. Just leave it the way it is. We'll explain later in the next session. And we create a matrix. First of all, we want to create a matrix for us to get the dimension. We cannot get the dimension from here. It must be a matrix. So we create a matrix of student data. We learned about creating a matrix where we call the vector here, and we specify other arguments. So I'll just run. I will not talk a lot about that. And we can now print the matrix, and that is the matrix. We learned how to give the column names, to give the row names, and we check the dimension here now. You see now the dim is working because it's a matrix. So the next section is to add the column to the data, add the column to the data, column names. We create column names and we add to it the way we did previously. And we can also see that we have added the column names. We go to adding the row names, everything we have learned, student ID not found. So student ID not found. Let me just go and run that again, and we will be okay. So here it is. So it can only run when let me just copy it from here to down here and then run it. It will now be available where we adding rows. Yes. So I just run it here. So I run it here. And yes, once I run it there, and now I can run it. I have now assigned the IDs to it, and I can now assign the rows and now print the whole data again. So you see, my data is now looking neat. So we can perform the row sum and the column sum, the one we did in the previous example. It's just like we are doing the review of what we have learned. So we have assigned the row sum, and now we can see the row sums. The row sum stands for the scores, the total scores for each student. So we run, total scores for each student is there. And we can see now the total scores per subject. Also we run, which is column wise. We call it column sum. And there we go. For science, maths, and that. So we can add also another subject to the matrix we already have, which is history scores. So we create a vector, history scores, and we use the cbind to combine the original data we had, which is student data, and the new vector. We combine a matrix with the vector. And just see how all these things are going to merge together. You will not even struggle. And when you print this, the whole data, all data, you see, it fits pretty cool. So history scores has been added at the end. Okay, add a new student. We can add a new student, which means adding a new row. So you already have the column names. You don't even need that. So we create a new data. New matrix. After creating a new matrix for the new student, we create a row name. We create the new student marks, and then we create a new matrix for the new student. And then from there, after creating the new matrix, that is the matrix of the new student, and we now assign the column names into it. We assign the row names into it, and we print the new student matrix. Yeah. And now we want to merge all these matrices together, the student, the new student, and the original data we had. We're using the rbind because we are binding at the row, at the bottom, because it's 106, at the bottom of our original data we had. So we do that just this way. And there we go. We have combined everything together. And now we can compute the totals if we want, using the column sums to compute all the student marks, the subject scores, total subject scores, and we can print it out to the user. And we see maths total scores is 457, science is 463, English score is 478. And we can compute also per student to see what the students have been scoring. And we see the students' marks is here, 320, 332, and so on and so on. And we can also select matrix elements using the brackets, the curly brackets, the square brackets, sorry, and we can specify the range of elements we want to select the way we just learned. Matrix name not found, matrix name, okay. Just forget about the matrix name here. This one is just a demo. And I can just comment it out. We are using hash to comment out. So we print the data, and maybe we want to access the first element of our data. The first element of our data, you see, the first element in our data, which is 85. If we want to select the first row, we used 1 comma, and then we close. That's how we select the first row. So let's see. That is the first row. And if you want to select the first column, we use comma 1 and comma 1. Yeah, and there we go. Yeah. And if we want to select maybe the third row, we can just change this to 3 and we run. There we go. And if we want to change maybe the third column, we can also do that. Okay. So that is it. And this now is about a data frame. The final part is about creating a data frame. And we want to create a data frame and it's visualize our data a little bit. And as we prepare for the next sessions, we are just finalizing this session. So we create a data frame using the SQL. We combine, first of all, create a vector, the first vector, create a second vector, create a third vector. We have learned this, and also create the fourth vector. So create a data frame, we use data.frame to combine all the vectors together as a vector, as a data frame, like that. And now we print our vector, our data frame. You see how data frame is beautiful? Now we can compute anything with our data frame. Maybe we want to check for correlation plot about our data. So correlation plot about our data, we load was built in R. Yeah, this is just okay. It's loaded already. So if you see when the message was built in R, this is just more information. So you are less. We continue. It has already been loaded. We load Corel plot from the R library. And there we go. If it is not in the library, you'll be told to install a particular package in R, which will be able to do that. It's a simple step to run packages. We'll learn more about that when it comes in the second session. So correlation, we want to carry out a correlation of our data. So correlation plot. Let's plot this. Yeah, in R. And there we go with our first correlation plot, checking the relationships between different variables, the axis, the shots of target, the points that we have in every scenario for each team, and the shots on target for each team. So we just try to see if there is relationship. So you can see there is a scale from -1 to 1. So correlation, we are going to learn more about correlation. The values of correlation usually ranges from -1 to 1, where 1 means a strong positive correlation and -1 means a strong negative correlation. And as the color scale, we can also see the color scale. Deep blue means that it is a strong correlation, and the red color shows that there is a negative strong correlation. Deep blue means that there's a positive strong correlation, and deep red color shows that there's a negative strong correlation. So we can see that the diagonal is correlation because the correlation between one variable and itself is always 1. And maybe we can check a relationship between there is a strong relationship between the points and the shots on target. Yeah, and that is actually true. When we have shots on target, and maybe we say many shots on target shows a lot of points. There's a relationship that there is high relationship between points a team has with the shots on target. That's very interesting. And the shots of target have shots of target have a minimum relationship with where shot of target and where the points and shots of target. Yes, there is also an average a negative tendency of relationship when it comes to the shots of target. The more you have a shots of target, the more we have less points. In short, there's a negative relationship between the points and the off target. Of course, that's what we are going to discover more in the coming sessions. And we are going to load data into R just in form of data frame, and we'll be able to analyze a lot. And what else can we note here? Assists and points. Let's see. A team that has many assists, can it have points? So assists and points. And also, there is some sense that the assists and points, there is that almost to no relationship. Almost to no relationship. There's a very less negative relationship between that. But the strong relationship exists between the shots on target and the points. And the shots of target and the point shows are kind of a strong negative relationship. This one is a positive relationship. And we can discover more about data. And we can also change these to numbers in R. We are going to discover more about this in the next class. And you can change it to numbers actually to interpret this data easily. And you can see the numbers here, the negative numbers and the positive numbers. So you see the shots on target and the points is actually a positive relationship. Positive relationship. That's kind of a good relationship because above 0.5. Yeah. And all the others have a negative relationship when it comes to the points. Nice. We can again have another view of the same thing in terms of a heat map in R. But anyway, we are going to discover this in the next session. Thank you so much for attending our session today. And let's meet in the next class. Let's meet in the next class.